2 years as a mentor. I'm currently mentoring for Bad Robots 1014. So now on to drivetrains. It's very important you choose the right drivetrain because it's probably the most important system. Without it, you can't move anywhere. So there's multiple different options to choose from. Each has their own strengths and weaknesses. And although some of us would like to pick the coolest when you think about it, a little more reasonable. Heard of a drivetrain where there's a Leco where it moves everything, but not the best performer. So some of the things to think about is the agility. So how quick you're going to be moving around and turning. Also the strength. So if you can push other people out of the way, or if you can stay standing and defend. Also another thing is motors. So you have a limited amount of motors. I think it was 6 sims last year.
Yes.
So if you used 4 on your drivetrain or 6 on your drivetrain, you couldn't use them for other stuff. You also need to think about programming. As a mechanical guy, I always forget about it. But some drive systems definitely are more intensive and are definitely more difficult to program. Also, another thing to think about is ease to drive. So some systems are very intuitive to pick up, or some things might be a little harder. To that point, just because they don't go sideways doesn't mean your driver is going to be able to quickly do that. You also need to think about transversing obstacles. So you have to think about where you want to go on the field. So sometimes there's a ramp in the middle, and you'll sacrifice going over the bump versus going over the ramp. And then also a big part is design, because some things are very costly and very hard to build. Oh, another point to that, repair. You really need to make sure your drivetrain is reliable, because breaking it in the match or during the competition is not very much fun, because it pretty much puts you out. So some of the big ones are tank, mechanism, swerve, and slide. So at tank drive, the wheels are driven independently. So you can have sets of 1 to 4. So it is very simple and easy to build. It has great pushing power, and a lot of people can pick it up and drive it right away. But it definitely limits agility compared to other drivetrains. Next one's mechanism. So it uses 4 mechanism wheels. The wheels have separate wheels at 45-degree angles, and it can be pretty easy to build. It does add a considerable weight to it though, because you need each wheel driven independently. And with mechanism, you don't have much pushing power, and you really need to make sure you're on level surface. Otherwise, you'll have problems. So it's very easy to get caught on objects. Next one is swerve. It's always really cool, but it is very hard to build. And I looked it up last night on Mark. They do sell a module, but it's $350 per module. So it's not a very cost-effective option. To it, it adds a lot of weight. Because not only do you need the module here, but you need 4 motors to drive the bottom wheel and 4 motors to drive the top. So this is usually one most teams will stray away from. Next one's slide. It's pretty similar to mechanism. So you have 4 wheels in the corner and 1 right here. They're all Omni wheels. So it's also pretty easy and cheap to build. It's very agile. It definitely has no pushing power. Next one is hollow-matic, and so the Omni wheels are at a 45-degree angle. So it is also pretty agile, but again, doesn't have much pushing power. So if we look at them kind of quantitatively, we can kind of see that which ones are going to be better at agility, strength, in those categories. So things to decide when you're choosing a slide drive is if agility is very important, but you don't need much pushing power at all. If you do go with slide drive or mechanism to that point, it's best to build a practice robot, because drivers really need to get in the groove of driving around and turning sideways around other robots. So mechanism is similar to slide, but there's a lot more resources out there to build a mechanism, and They're usually more stable than a slide. So tank drive, it's pretty much what most teams pick. And it is, although some teams don't do it because they have a lot of other resources. So some things about tank drives is if you want the most power, all the wheels must be going. And so you can vary the number of wheels for a tank drive. You don't just need to have 4 or however many. Another big point is long wheelbases are difficult to turn. So if your wheels are spaced out really long, it can be very hard to turn your robot. So one of the simplest is 2-wheel driven, and so you can have wheels on the back and casters on the front, or wheels in the center and casters on the outside. And so it makes it very easy to turn, but you don't have much pushing power because you only have 2 wheels on the ground. The next is 4 wheels. So it requires a longer base because you need to put those extra wheels in. You definitely get more pushing power, but when you add more wheels, you're going to create more friction when you turn, so sometimes you might need to use a lower friction wheel to get that turning power. I think 2 years ago, 1014, they had a robot where it turned and it couldn't turn at all because it was pulling 200 amps from the battery because it had too much friction from the wheels. So you can up them to 6-wheel drive, you definitely get more. One thing I forgot to mention about 4-wheel drive is one great benefit to doing 4-wheel drive is you can have 2 in the middle, 2 in the back, and then 2 omni wheels in the front. It provides more turning, although your turning point is more to the back of your robot. And so 8 wheels beyond, it gets kind of ridiculous, but it usually has to do with traversing obstacles. So motors. Any questions about drivetrains? Okay.
This one.
Oh, sorry.
So why would you choose polynomic over mechanical?
It's a lot lighter, and it's usually seen a lot more in FCC where you don't have as much defensive power, and you're not as heavy of a robot. So for motors, the big one is the sim, and that's used for your drivetrain. And I'll get to this efficiency later. The next one's the back motor, the tiny one. It's great for medium power applications if you gear it down. It has a really high spinning speed. The window lift is a great one. What I mean by lock pull right here is it has worm gear. So once you turn the motor off, you can't turn it. That can be a great benefit if you're saying having something that's pulling down, holding a climber. It will stay there and you don't have to worry about continuously giving power. And then you have the mini sim. It's mainly used for appendages. And then you have some other motors like the Dayton motors and the Beck motors. So some things to think about for motors is their stall torque. So if you just held it, how much torque would that be? And then the stall current, which, as I said earlier about our 1014 robot, we were getting that. So the free spinning speed, and then the motor power, which is either voltage times the current or the torque times the angular velocity or free speed. So the sim motor, so the most common. So one thing to note is this power curve. You can look them up online. So if you look, as you increase the current, you'll increase in torque. And then also, if you look at the relationship, the efficiency, so if you want to be the most efficient robot, or if you notice you're running out of power at the end of matches, you kind of want to match for that 4,500 in the middle. So the window lift. As you can see, the efficiency is more to the left. One thing to note is if you haven't worked with window lifts, they're quite annoying to mount because they have these 3 mounting holes right there, but they're not level. So you have to think about how to mount it. to the bag motor. As you can see, it does spin a lot faster, but if you gear it down, you're still going to have less torque than some other motors because it is a smaller motor. So it's normally geared down. The mini sim, I don't know how much to say about that. The gearboxes. So once you have your drivetrain motor, you need to gear it down. You have to think about how fast you want to go or how much pushing power. So if you really want to climb over those ramps or push robots out of the way, you need some torque. Or if you really want to zoom by, you might not want to gear it down as much. So there's the single speed VEX. And so it houses 2 sim motors. And so a lot of these gearboxes have different torque ratios that you can pick. And one thing to note is if you were to have 2 motors for your entire drivetrain, you're going to have a lot less power than 4. I've read some that having 6 sims versus 4 doesn't really provide that much torque. And it will eat a lot more power, so usually it's best to only go with 4 sims. Some other single-speed gearboxes, 1014 uses these a lot. The Tough Box Mini right here and the Tough Box Nano. They accept the sims on the back. So I've worked with this a little bit, the Super Shifter. So it has 2 sim spots, and then it has a pneumatic thing, pneumatic dog gear to shift gears. So it can provide a lot of versatility if you want to shift the lower gear and push those robots away, shift to higher gear and rush across the field. They do have some issues of complexity. They can break, and then you do go with this option. You will have to put pneumatics on, so if you weren't originally planning, that's a lot of extra weight. And as well as when you're in high gear, it's a lot harder to turn. You lose that agility, and you're already a tank drive with this gearbox, so it doesn't really, it can be quite cumbersome for a driver if he doesn't get in the intuition of shifting the lower gears to turn. So for a bag motor, this would be a good gearbox option. So as you can see, there's large gear ratios, 100 to 1. So if you really wanted to tone it down, if you just wanted to turn something real slowly, you can get gearboxes like this. So once you have your gearbox, you have to think about your shaft. So there's hex, cylinder, and spiky hex. So kind of asks you to do a lot with your team on which one you choose. 1014 does a lot of the cylinder shafts. Metrobots 3324 always goes hex. So you just have to be considerate on what you're ordering and make sure it lines up with everything, all your other parts. So once you have the output, you need a hub. And so if you want to get from your shaft to your wheel, you can just straight connect the hub straight to the wheel, and it will work really well. It's easy because it's just put things together, but it really has an issue of you have very limited on where you want your wheel to be because your gearbox and motor has to be directly in line with it. Also, if you're pushing too much on your wheel, it can bend the axle in the gearbox, and that can either make the gears in it jam up and stop working, or break the gearbox. Another option is to go with sprocket and chain. One thing about sprocket and chain is they always stretch over time. And so they can get a little bit tricky with tensioning. And if you don't have the tension right, your chain can break or slip off. And if you do lose a chain on the field, you can lose points as a penalty. And one thing to note is if you look up your chain pitch, you can actually calculate how many links you need so you can properly space out where your axles are going to be. And the best thing about chains is you can still further reduce your gear reduction but they do add some weight. So for wheels, one thing to think about is how small or big your wheel is. So with a smaller wheel, it's less gear reduction. It's kind of like a sprocket and chain. It's less weight and it can help lower your center of gravity. Where a large wheel, you might have to up your gear ratio, but it can help you get over some obstacles. So the different types of wheels. So you have your standard wheel right here. Your performance wheels, which are right here, and then your rubber tread. I believe those are what comes in the kit of parts. Can't remember. Then you have your lock-on wheels right here. A lot of teams use those. One thing to note is it's very important to decide on which wheel tread, because if you were to use a lower friction like this, it'd be a lot easier to turn with tank drive, although you would lose some pushing power. And then there's pneumatic wheels. You don't see a lot of teams doing it, but if you do go that route, one thing you can do is you can adjust your friction with changing air pressure. And so that can help. So the other wheels are the Omni and the Metronome. So the Omni are just the other wheels perpendicular, and these are at a 45-degree angle. Any questions? One great source is the Team 1114. They have a great website for all categories, as well as, probably heard this already today, Delphi.
Awesome. Thanks.